Question 16. Figure 4 shows the plan view of a design for a swimming pool. The shape of this pool consists of a rectangular section joined to a semicircular section as shown in figure 4. Given that AE is 2x meters and ED is y meters and the area of the pool is 250 meters squared, show that the perimeter P meters of the pool is given by P equals 2x plus 250 over x plus pi x over 2. Right, well, first of all, we need to realise that this semicircle is radius x because the diameter is 2x. And so when we look at the area, it's going to be the area of the rectangle plus the area of the semicircle. So we're looking at the area of the rectangle plus the area of the semicircle. And that's going to be area, which we told is 250, is equal to 2xy, that's the length. The length of the rectangle is 2x and the width is y, so that's the 2xy. And the area of the semicircle will be pi x squared divided by 2. So it's 2xy plus pi x squared divided by 2. Now in the formula for the perimeter there is no y, so we're going to need to eliminate y. So I'm going to use this equation to make y the subject and find out what it is in terms of x. So I can say that 2xy is equal to 250 minus pi x squared over 2. So xy is equal to 125 minus pi x squared over 4, and then dividing through by the x, y equals 125 over x minus pi x over 4. Now I need a formula for the perimeter, and the perimeter, looking back at the diagram, will be 2x for that top length plus 2y for the two side bits plus half the circumference of the circle, so that will be 2 pi x over 2. So the perimeter is equal to 2x, the top line, plus 2y, the two side bits, plus 2 pi x, the circumference of the circle, divided by 2. So the perimeter is equal to 2x plus 2y plus pi x. And that is 2x plus 2. Now let's have a look back and see what y was. Y is 125 over x minus pi x over 4. 125 over x minus pi x over 4. And then we've got plus pi x on the end. So that comes to 2x plus 250 over x minus pi x over 2 when I multiply through by the 2 plus pi x. And that's equal to 250 over x plus 2x plus pi x over 2 as required in the question. Part B. Explain why x is strictly between 0 and the square root of 500 over pi. Well, x can't be negative because it's a length, and it also can't be 0 because then you've got no swimming pool at all. So let's make a note of that first. X can't be less than or equal to 0 because then there'd be no pool at all. What if x is the square root of 500 over pi? What's the significance of that number? Well, the area of the semicircle is pi x squared over 2, and that would be pi times the square root of 500 over pi squared over 2, and that gives us pi multiplied by 500 over pi all divided by 2, and we see the pi's cancel and the 500 over 2 is 250. So that means that the whole 250 meters squared of area has been taken up by the semicircle and there's no room for a rectangle. So x equals the square root of 500 over pi implies semicircle equals 250 meters squared and no rectangle. And since we're told that this pool has a rectangle and a semicircle, we can therefore deduce that x must be strictly greater than 0, so we have a pool, and strictly less than the square root of 500 over pi, so it has a rectangular portion. Part C. Find the minimum perimeter of the pool given your answer to 3 significant figures. Well, here's the formula that we found for the perimeter. P is 250 over x plus 2x plus pi x over 2. And we'll first write that in a form that's easier to differentiate. P equals 250 x to the minus 1 plus 2x plus pi x over 2, which means dp by dx is equal to minus 1 times 250 is minus 250, x to the power minus 2, 1 less than minus 1. Differentiate the 2x, I get plus 2. Differentiate plus pi x over 2, and I get plus pi over 2. So dp by dx is equal to minus 250 over x squared plus 2 plus pi over 2. Now at a stationary point, dp by dx is 0, which means that 0 equals minus 250 over x squared plus 2 plus pi over 2. Taking the minus 250 over x squared the other side, we get plus 250 over x squared is equal to 2 plus pi over 2. Multiply by the x squared and we get 250 equals 2 plus pi over 2 x squared. So 250 divided by 2 plus pi over 2 is equal to x squared, which means that x is the square root of 250 over 2 plus pi over 2. And if we put that in our calculator, we get x equals 8.367. Taking it to 4 significant figures, and I'll round it to 3 significant figures when we get the final answer. So P is equal to 250 over x, 250 over 8.367, plus 2x, so that's 2 times 8.367, plus pi over 2x, so that's pi over 2 times 8.367, and if we put that in our calculator, we find the perimeter is 59.8 meters to 3 significant figures. Now the question doesn't actually ask us to prove it's a minimum, it could be a maximum. Let's have a look. If we look at d2p by dx squared, let's go back to dp by dx, which is this expression here. Let's go to the one above, which would be easier to differentiate again. If I differentiate that, I get minus 2 times minus 250 x to the minus 3. So that's 500 x to the minus 3. And the other two terms were constants, and so they would disappear. And we can see that is 500 over x cubed, and for all positive x that's greater than 0, therefore indeed it is a minimum. But we weren't actually asked to show that in the question.